Hello, welcome back. In this lecture, we're going to begin a discussion of iteration in some further detail, particularly iterators. So we've talked about iteration before, primarily in the context of describing constructs like for and while loops that allow you to access the elements of a collection of objects in a sequence in different ways. Colloquially, an iterable is an object that can be for looped, and an iterator is a companion that enables the iterable to be for looped. So in some sense, an iterable is an object that comes with an iterator. So in this lecture, we're going to see what an iterator is. We're going to look into the operation of for loops in a bit more detail, and use the iterator construction to re-implement looping over lists in a technical and detailed way. This will build our foundation for constructing custom iterators with novel user-defined behavior, and that's coming up in the next lecture. Okay, so we've already seen lots of containers. So containers are objects that hold other objects, and our favorite container and simplest container is, of course, the list. So for W in to boldly go, so that's a list with 3 strings in it, to boldly and go, I'll print W, and lo and behold, I was able to successfully for loop over this list. Now, what I want to start emphasizing in this lecture is that our ability to for loop over lists is not something that we should take for granted. It's something that had to be specifically programmed in, because not everything that holds objects or even looks like a list will support iteration. So here's a really simple example. I'm going to call this boring list. It's a class. So class boring list. So what is it has? It has a custom initialization method, def init, self, and L. So a boring list will hold the list that I'm calling L as an instance variable, very simple. And then just to make it look like a list, let's also give it a nice string representation. So return str self.l. So I'm using the str representation of the list that the boring list holds. Okay, so this class, it holds a list as an instance variable. When you print it, it'll print something that looks a lot like a list, but it won't support iteration. And let's check that out. So if I make a boring list, B, 1, 2, 3. So here's a boring list. B is now a boring list. I can print B, and it sure looks like a list. And so if you were not being excessively cautious, you might say, hey, I should be able to for loop over this. But indeed, you cannot. So for I in B, print I, this will give me an error because boring list object is not iterable. I get a type error. So the boring list class, it looks like a list, it smells like a list, it prints like a list, but it's not iterable. It doesn't have the magic that lists have that allow you to access their elements in sequence using a for loop. So what is the missing ingredient here? The missing ingredient is the iterator companion class. Okay, so this gets a little bit complex. So in order to take something like our boring list and turn it into something that we can for loop over, to turn it into an iterable, we need 2 things. First, we need to create a companion iterator class that implements a next method. And we'll see what that means in a moment. Briefly, the next method tells the iterator class to count, for example, 0, 1, 2, 3, 4, or item 1, item 2, item 3, item 4, in a user-defined sequence. Now, in addition to the iterator class, we need a custom iterator method that tells Python how to construct the iterator from the base class. Okay, so 2 steps. We need an iterator class, and we need the iterator class to have a next method. We need an iterator class. We need the iterator class to have a next method. Okay, so let's, with that in mind, let's try making our boring list iterable. So we need 2 things. We need an iterator class, and we need a next method in the iterator class. So First thing, we need to tell boring list what to do in order to create an iterator class companion. So we do that by implementing the iter magic method. So let's def iter self. And what I'm going to do is I'm just going to return boring list iterator of self. So this is boring list iterator is the name of a class that I haven't implemented yet. Okay, so this function will not work right now. But what I'm going to do is I'm going to say, hey, whatever this class is going to be, give me one. And in particular, give me one initialized with this particular object. So not just any boring list iterator, but a boring list iterator that is initialized with this boring list. And just for transparency, I'm going to give this a print command as well. So I'm going to just give us a little hint that boring list iter was called when we call this method. So right now, this function will not work because I have not implemented the class boring list iterator. So now let's implement the class boring list iterator. So what we've done so far is we've given Python a recipe for constructing a boring list iterator from a boring list using the magic iter method, but we haven't said what the boring list iterator is, and we haven't implemented the next method. So that's what we need to do now. So class boring list iterator. So what do we need to do? First, we need to know how to create a boring list iterator. Here's what's going to be in my boring list iterator, def init self and BL for boring list. So when I create a boring list iterator, so this init self and BL method, that's what's being called right here. That's what's being called when I return boring list iterator of self in the boring list.iter magic method. Okay, so def init self and BL. Here's what I'm going to do. Just for transparency again, I'm going to print boring list iterator object created. Okay, and then I'm going to store the list that the boring list object holds. So I can just store that list as self.l. And I'm also going to initialize a counter I at 0. So you can think of the counter I as saying, hey, which item in this list are we currently at? What's the current element of the list? Okay, so the last ingredient that we need, remember so far we've told boring list, we've implemented the iter magic method that will produce a boring list iterator. And we've given Python a recipe for initializing a boring list iterator. So we're most of the way there. The last thing that we need to do is give the boring list iterator a next magic method. So def next of self. Okay, so to do next, here's what we want to do. We're going to first, again, for transparency, boring list iterator dot next called. Okay, great. Okay, so here's what we need to do. Our next method is going to step through the elements of self.l, and it's going to raise a special exception called a stop iteration exception at a moment when we choose. And the way we should choose it is such that it corresponds to the end of the list. Okay, so here, let's implement that. So if self.i is greater than or equal to len self.l, so this is asking, have I exceeded the length of L? Then I'm going to just print here for transparency again, stop iteration exception raised. And just like I said, raise a stop iteration exception. So this is a special kind of exception that says, hey, stop iterating through whatever I'm iterating. Stop calling the next method, in other words. Okay, and then I'm just going to implement self.i so that I'm ready to go grab the next element of my list. And finally, I need to return a value. Okay, so what value should I return? Well, I just incremented self.i. So if I imagine starting at the very beginning, self.i started at 0. Its value is now 1, but I need to return the 0th element of the list. So the right thing to return is I'm going to return self.l, self.i minus 1. So on my first iteration, that'll be 0, which is what I would expect. Okay, so this looks like a lot of work just to get a for loop, but this will be worth it later on. This is just an illustrative example. So what I've done is I've created a boring list that does not support iteration, but then I have added to it a boring list iterator. What happens when the boring list gets for looped over, which will now work, is first it's going to construct an iterator using the magic iterator method that we defined for the boring list. That magic iter method will construct a boring list iterator. The boring list iterator has a next method, and the next method is what will be used when we do the for loop. So let's just check that this works. So b equals boring list to boldly go again. Okay, so now what's going to happen is that we're going to successfully loop over B, and we're also going to print out all these different messages that I included at different stages, so we can kind of see the sequence of operations here. So for W in B, print W. Let's see. Oh, I got an error. That's because I haven't defined these classes yet. I need to actually run this code block. Okay, so first of all, notice that now we did not get an error. Fine. What we did get is a sequence of messages. Okay, so what's the sequence here? When I did this first line for W in B, that automatically called the iter magic method. The iter magic method is always called when I attempt to for loop over something. Then a boring list iterator object was created by the iter magic method. Then in the body of the for loop, we began to call the next method, the next magic method of the iterator class. I misspelled iterator here, boring list itator. We call the next method, the next magic method of the boring list iterator class over and over and over again until we get to the last call. So here we called it for the first time, and it checked that we were actually at the end of the list and raised a stop iteration exception. Okay, so this is working. Let's just do this in slow motion. Okay, so let's do this in slow motion. So in slow motion, what the for keyword does is it calls a particular function iter on B. And what iter does on B is it does whatever it's supposed to do according to the iter magic method associated with B's class. Okay, so when we do, let's say BLI is the result of iter B, and we can see that indeed BLI is a boring list iterator. So when I do iter of B, I call the iter magic method of B's class, and I got a boring list iterator. And now I can call the next function on BLI, and the behavior of the next function is determined by the next magic method of the boring list iterator class. So I can do this over and over again until I raise a stop iteration exception because I got to the end of the list. So this is what's going on behind the scenes every time you call a for loop in Python. Implicitly, an iterator object is being created from the iterable that you feed the for loop, and then that iterator object's next method is being called over and over again until a stop iteration exception is raised. Okay, if you want to write a little bit less code, you can. So there's no rule that says that the iterator object cannot be the same as the iterable. Okay, they don't have to be two separate objects as long as there's an iter magic method and a next magic method. We can attach these to the same class. So here's an example. This is my initial boring list. I've just added self.i equals 0 to the init method. So this boring list has a notion of what element we're at. And I can use that to define essentially the same next method. But before I do, I still need an iter method. So my iter method is deliciously simple. So def iter self. I'm going to start here by ensuring that self.i equals 0. That means I'm always going to get the right answer. If I try to for loop multiple times, I'll always start at the beginning. And then I'll just return self. So when I try to get the iterator corresponding to this iterable, I'll just get this object back. So there's no transformation, no additional object. And now I just need to implement the next class. So the next magic method. So next self, if self.I is greater than or equal to len self.l, this should look pretty familiar. Raise stop iteration, same as before, and then self.I plus equals 1. So we increment self.I, and then finally we return self.l at index self.I minus 1. Okay, so now we have all the right ingredients. We have an iter magic method that returns an iterator, but the iterator that it returns is the boring list again. The boring list is now an iterator because it implements a next method. Okay, so let's try that. Let's see, b equals boring list to boldly go for w in b print w. And indeed, this now works. So this saves us a little bit of effort because we can implement the next method directly inside the class that we're working on. In other cases, however, it is convenient to have multiple classes, an iterable class and an iterator class. Both of these are good, valid programming approaches that are useful in a wide variety of contexts. Okay, so in this lecture, we really went pretty deep under the hood of what a for loop is doing behind the scenes. It's taking an iterable, creating an iterator, and then calling the next method of that iterator. We've used our deep understanding to essentially just re-implement for loops for lists. So that's not too exciting. In the next lecture, we'll see a more complex example where we actually define some novel behavior according to our needs.